There you go. Okay. Yeah, we were gonna do them in November. We'll probably delay that now, unless we do some extra classes or something. It depends on if your guys' school recloses or not. Otherwise, we can always delay to next year. What we were going to do with the Crawford schools is release a poll to the students and the parents to gauge where everyone wants, and we'll propose a few different dates.
Okay.
Luckily, because it's not fixed to a normal school year, we have pretty, we're pretty flexible in terms of when we can write. Just need a classroom, basically, and students, of course.
And do we know how many people are going to join today?
I don't. I mean, I assume Creflo, Tariq. Tadi didn't say anything, but I imagine he would join. Might be some startup costs again, since, has been 2 weeks since we...
Yeah. And school's been really tough this past couple of weeks.
I mean, have you gauged? Have your teachers started discussing whether or not like reclosure will happen, or are you guys discussing exams?
We've just been getting a bunch of assignments and stuff. We're still in term 2.
Okay.
So we have to do 3 terms of work in this half a year.
Yeah.
Which
okay, that's quite hectic. It seems a little bit crazy, actually.
Yeah. They are cutting some stuff out and all that, but yeah, our teacher said we must just wait for confirmation by like Wednesday-ish, tomorrow.
Okay.
Yeah.
Cool. Yeah, difficult situation, very, very tough.
Indeed.
Yeah, and you guys look like, it seems like Roosevelt has been harsher than the other schools I tutor at least.
Well, the reason because of that is because they didn't do online classes for us.
Yeah, precisely. Yeah, because Bryanston was doing online classes and so was Crawford. So I think that's why they didn't have to go back as harsh. But yeah, the other thing is that Bryanston, the actual school, includes us in their schedule, which is quite a good thing. It seems like Roosevelt just didn't really consider extramural activities like this when they were deciding on your return to school schedule.
Well, the boys go to school on Monday, Wednesday, and Fridays, and girls go on Tuesday, Thursday, and Saturdays. So it's not as harsh as making us go back every day of the week.
Yeah, that's true. It's just the extra time, makes it a really long day.
Yeah.
Buddy made it. Yeah, I guess some people are just running a bit late. That's fine, I suppose. Yeah, I think also the other thing is we should start using mics more, because it is much more interactive that way than typing.
I'm only using the microphone because it's connected from my classes.
All right, okay, cool. Okay, Senpai Einstein. Who would that be? Creflo or Phil? Because they're the ones who use weird nicknames every single time. Okay, in chat. Hi, am I late? A little bit. We'll wait for some other people. Hopefully more of you guys join. Is your schedule still harsh today? Did you guys have to forego doing some homework to be here or something? Okay, let me mark you guys off. So it's here. Because yeah, it is very difficult to get an idea of your schedule. You were busy with guitar practice. Interesting. Okay, and yeah, who are you? I can't for the register. Yeah, no. I know who you are, Taddy. You're using the same nickname as usual. Creflo. Okay, cool. I thought it would either be you or Dap Bear. So, and I was leaning towards it being you, because I don't know if Philip is joining us today. Hopefully he is. Bryn did say that he Bryn is like out hunting or something. He's on like a holiday, so he wouldn't make it this week. But other people, we're gonna have to start, I think, phoning parents of people who aren't attending, because it's a bit. I don't really want to, but I do see that it is necessary, I suppose. Because we can't delay too much more. I'll wait. Yeah, does make things much more difficult. Okay, well, in the meantime, hold on, let me share my screen because there's something we're doing before we start anyway. So at least it can refresh your guys' memory. I did make this one quite difficult though, but we'll see how it goes. Okay, so should I share just the, no, I'll share the whole thing. Okay, so here we are. Okay, so you guys can see the link and the code at the top, right? I can also just post it in the chat just in case. Let me do that. But yeah, if you guys want to speak as well, please try to use your microphone, because that would be more ideal, I think. But so you can go to this URL, www.menti.com, and you're going to type this code. You don't have to put the spaces where it puts the spaces, but like when you go to that page, it'll ask you for a code, and you must just type this one, 318417. And yeah, you don't have to make an account or anything. So what it'll do, it'll ask you to give it a nickname. It'll recommend you a unique nickname. So you can just use the one it recommends if you want. So you can just click through. You can put your own nickname if you want to, but it is a little competition. So you might, if you want, you can make your nickname anonymous, I suppose. Although I suppose it doesn't make that much difference. So yeah, do what you feel. Put whatever nickname you want. I think it's best if you can still, if you can do it on your phone or something, so you can still see my screen when you have that open, if you can arrange it that way. Otherwise, it is fine to only be able to see the one. Okay, yeah, so I see one of you has joined. We'll just wait for the other people to join. Okay, cool. All three of you seem to be here. Dual monitors. Yeah, that would be the best way, 100%. I need to get a dual monitor set up at home here, because it is super effective. Okay, so I did make this quite difficult, but it'll help us revise the wait, I do want to see, I guess, is that for the recording? Because I'm using, okay, cool, it is recording. I'm using Zoom to record the lectures now, rather than that Kazam thing, because it has a better format. Anyway, Alt tab, yeah, Alt tab can work as well. Make sure that you're looking at your screen sort of nowish though. Is this like a Kahoot ripoff? I don't know what Kahoot is. It might be. Okay, so yeah, let's just get started. Unfortunately, way fewer people than I thought joined, which is a pity, but we'll make a plan, I guess, for next week. We need to start. Cool, so it'll ask you a bunch of questions. What do we call the blueprint of an object? Okay, Foster answers do score more points. You don't remember these. Ooh, tough luck. Maybe you might get the next ones though. So that's it is time. Yeah. Well, I mean, some of the questions. No, but it's good that it's rusty, because this is what this is for. This is why we're going to be doing this from now on, because this will allow us to refresh our memory. Ooh, one of you didn't get an answer in time. Unlucky. Okay, nice. Yeah, so it is a class. No, I don't expect that. But do take note of what is correct though, hey? So you can see like the little bar graph on my screen and stuff, right? So at least remember what's going on. Yeah. So it can be like, you can use this for learning as well. It'll remind you of the questions, that the kind of questions they ask, remind you of the content as well. Okay, on to the next question. What do we call the type that references / signs for a method? Ooh, this one was a difficult one. I even felt mean when I included this one. Ah, you answered. Let's see. Ah, close. I mean, at least I hope then you guys were split between these two. Okay, you were split between these two. So remember, we often call the delegate like the thing that enforces the contract. So yeah, the delegate is the correct answer. Yo, Creflo, geez. Okay, so let's see. What do we call a class that sends an event notification? What do we call a class that sends an event notification? I think probably shouldn't say class. Nice. Yeah, okay. I like it. I mean, yeah, good guys. I mean, how many questions? There are, I think, 2 more. I'm not sure. Why, Teddy? Are you getting worried? Okay. No, don't worry though. Don't worry. I mean, it's obviously, this is just for a reminder. Yeah, so then obviously we would say, what do we call the one that receives the event notification? This should actually say method, I think. Yeah, this should say method, I think, or object. Oh, well. Which of the following class members should we use to define behavior? This one I would want you all to get. All of you. Unless you missed the one lecture, because we did, you've seen this question before, is the reason. When we did the review of the test, this question came up in the section 2 knowledge assessments and the mock test. And yeah, the key is in that word behavior. We link that to one of these. Okay. Close. No, I mean, it's no problem. Yeah, at least now you'll know, right? If you're asked about behavior, the answer is almost always method. Okay, cool. The keyword refers to the current instance of a class. The current instance of a class. So this one, you're allowed to type what your answer is. And it accepts a few different formats as well, like spaces and stuff are fine. So just, okay. So, I mean, I can give you a hint. We would say something like, I don't need to, you all answered, or skipped, I don't know. Okay, someone says static, interesting. Okay. So the correct answer is this. You guys remember the word this, right? You remember the word this? You don't, okay. All right, but this was the correct one. I'm gonna go over all the videos sometimes. Okay, yeah, I mean, the main important things would be going over the reviews for the tests and stuff, for like the mock test and all of that sort of thing. Okay, yeah, I think Krefler, you had a very strong start, hey? because you got those 3 in a row. But yeah, wrecked. Well done, well done. See, and this is why you mustn't bunk the test reviews, Logan. They're important. But no, don't take this too seriously, guys. It was just to refresh our memories and stuff. But yeah, well done. Wait, what would it do if I clicked? I only got one answer there. Yeah, I mean, I think so. Which one would Creflo? Creflo did get one wrong, I think, or 2. And I guess you and Logan got that one right. Yeah, okay. Then I think you and Logan got that one right. And you just answered slightly faster than Logan. But again, I'm not totally sure. I only know the number of people who answered on which sections. Anyway, though, yeah. So I figure I'll prepare like one of these. I'll prepare one of these like each time, and sort of just, you know, it'll help us revise, and it's a pretty fun way of testing, I think. So yeah. Anyway, that's today's one. Hopefully that refreshes you on some of what we covered in section 2. Yeah, it's nice. And it also gets you, it like wakes you up a little bit. Ah, damn. I should have closed this. Oh well. At least the like, yeah, numbers and stuff weren't showing, so that's fine. Okay, so let's get cracking on this stuff. Control-Shift-F. That's such a complicated hotkey just for making the screen full. Okay, so after 2 weeks of putting it off, we can finally get started on the application lifecycle. Ooh, the other thing I wanted to show you guys, because what we'll be doing, and I want you to just bear it in mind while we move through things. So I have this, we made this site. Let's see, is it gonna load? Oh, it has to wake up. So what we've done is we've, yeah, it is. We'll finish at 6:30. Were you worried that it was gonna be 2 hours or something? 4:30, yeah. Wait, did I say 6:30? I meant 16:30 or something. yeah, okay. I meant 4:30. Yeah, 1.5 hours. Let me go. What we'll be doing, so I just want you to keep it in mind. We've made this website. Bryanston and Crawford have each added their own thing. No. So it has to wake up. So it goes to sleep. It goes to sleep if it's not accessed for 15 minutes just to save money. Well, it's free, but like it can only stay awake for 1,000 hours a month across all of the. So this is a website that we've made, and the other schools have added something to it. So Bryanston decided that we should make the background green. Crawford wanted to add a button saying free V-Bucks. And yeah, so we'll be able to add our own thing to the website, and we're going to do it in a way that's conducive with the application lifecycle. Okay, so we first have to learn about the application lifecycle. So let's get started on that. And yeah, you can visit the website, you can see it works and does stuff. Okay, I mean, yeah, it's pretty much the ugliest website in history, I think, but 4:30 equals 3 hours before 8, so 3 hours of rest. Cool. All right. So application lifecycle. The application lifecycle is split into 5 parts. You can see, I clicked the button. Yeah. So it's, yeah. So I'm glad at least someone got it. Good stuff. Okay. So the application lifecycle, you can see it on page 66 of the textbook. It's got 5 steps in it, and yeah, we can start going through. Oh, well, now I know not to click it. Okay, so the first step is requirements analysis. So it's on this step, we just find out what it is we're doing, basically. So we'll basically just figure out what it is we want to add, for example, to our website, or what system we want to make, whatever we want to build. So we're determining what they call the business requirements for the new application system, right? Like, it is a very catchy song, hey? It is a very catchy song. Ah, that's good. And don't let it go, Creflo. Keep it. Okay. Yeah, you can apply. What is the song called? Rick Astley. Is it Never? I don't know what the song is even called, actually. Anyway, yeah, just never give up your textbook is basically the joke I'm trying to make. Okay, so we're going to determine the business requirements. So, application development, system development, software developments, it's all good and fun to just program for no reason. But obviously in like the corporate world, in the real world, they want the system to actually be able to do something. Particularly, they want to be able to do something business related, right? Something profitable. And so this is basically where we discuss what are the requirements of the application that'll make it functional and usable, right? So that's requirements analysis. The next step is design. So this does include like the look of the website, but it's also more technical, right? So it's plans, models, architecture, very detailed idea of how the app is going to be created, how it's going to work, or how the system will be created and how it's going to work. Development, this is what we've been talking about basically up until now. Like, this is where you actually code, right? This is where you code, but it's also where you write like user manuals and do documentation and things like that. That all happens in the development phase. But we'll talk about each phase in more detail, of course. Then there's testing. So test that the software satisfies the requirements and industry standards. So black box versus white box is an important thing that we'll discuss in that section. Beta testing, alpha testing, all of that kind of stuff. And lastly, so actually, yeah, Creflo, you have your textbook. Is your mic working? Turn on your microphone. Tell us what the last stage is. Sorry to put you on the spot. Okay, you got to get it. I mean, we can wait, I suppose. In the meantime, can you tell us, Logan? What is the okay, cool, you're back. Okay, cool, makes sense. Yeah, get your textbooks, guys, open them on page 66. But yeah, Creflo, in the meantime, can you tell us what the last stage is? Okay, fair enough. I can, no, I don't have the PDF version of chapter 3 yet, so. Creflo, I heard you. Is your mic working now? Tariq, you're here. That's good. I must mark you on the thing. You missed our little quiz, though.
Okay, here we go. I was trying to figure out how to unmute your mic on Zoom.
Oh, okay, cool.
What was the question again?
So what is the last stage of this little cycle that you're seeing on the screen?
Oh, maintenance.
Maintenance, 100%. And what would that entail? What do you think maintenance, what would we do under that stage?
Maintenance.
We would do maintenance, yeah.
Yeah, maintenance.
we would keep the site functioning, right?
Yeah.
We would perform updates is one way of saying it. Yeah, cool. But we'll discuss all of these things in more detail as we go. Cool, so requirements analysis. So this is the first stage, right? We're gonna go through stage by stage and discuss how you might actually design an application. Okay, so how it'll usually start is there'll be a random either business person or investor or partner or something who will be running around, but the point is this person has no technical skills usually. Like this might be VITS, like the company you're developing for, or anything like that. Obviously not necessarily true if you're developing for yourself. But the point is there is always someone like outside of you to consider, right? Like whether it's the user or the owner or the investor or someone, there's always, you're not just developing code for yourself. Okay, so cool. Usually this person is called the product owner or business owner, and they don't usually have technical skills. So they'll be like, hey, I want to develop an app, but I don't have any real skills. Please help me. Okay, so they're lost in the wilderness, and they need an app developed. Okay, so what they'll be looking for is someone like this. Nerd shepherd is a jokey way of referring to them. More formally, they might be called a business analyst or a project manager. I see another person has joined, Ada. Okay, cool. Awesome. We're picking up a little bit. There are a few people we'll have to contact, and I'll have to open up the register again maybe during the break. Anyway, so we have this business analyst or this product owner who just is going to, basically they'll have a team, they'll have a group of people who do know how to develop things, and they'll say, don't you worry, I have a flock of developers who can create your application for you. Okay, so basically we'll end up, obviously these people are going to end up working together. Usually the product owner or business owner is not going to have like a realistic or technical vision. So this is an actual example. When I was in second year comp sci, someone approached me while I was like waiting at the Wits. Like Wits has a little student corner, and someone did actually come to me and suggest like an app for your phone where you drop it, and before it hits the ground, like this app makes it levitate somehow. Okay. Now, obviously, this is totally impossible. If you're at all technical, you would know that that's impossible. You can't make a phone levitate, right? Gravity.
Yeah, obviously.
Yeah, 100%. So the point is, this person, the product owner or business owner, won't necessarily know what's possible. I mean, it's a good idea. It's just impossible. Well, I guess it depends how you define a good idea, right? Whether that's a good one. So yeah, point is, this person won't know what's realistic or what's possible or how to describe the app that they want technically. They just have a vague idea. And so it's the business analyst or project manager's job to perform what's called requirements analysis. So we'll go through a few examples of what a requirements analyst will do. Basically, there'll be some gibberish that a project owner or non-technical person would tell you about the app that they want you to design. And we have to translate that gibberish into specific technical terms. Okay, let me just take off this jacket. Okay, into specific technical terms. So let's get started. So yeah, on the left, we'll have what the product owner says, and we're going to play analyst, and you're going to help me, ideally through your mics, because I think that probably is a better way to get through this.
Okay.
So let's say here, the product owner says, we want you to be able to upload videos to our site. So you see, that's a pretty broad thing, right? Lots of sites you can upload videos to lots of sites, right? Instagram has like shorter videos, YouTube has long form videos, et cetera, et cetera. So when the product owner says this to you, what technical things are you going to be thinking? Do any of you guys have any ideas? And you see, you do have to think about this because it is.
Okay, so this guy wants to be able to upload videos on his site, but he does, yeah, like you said, he's not specifying how long these videos are or what type of videos they are.
Yeah. So that's a good first thing to be thinking. How long do the videos have to be? And also, I mean, if we're running a website that needs to be able to have videos uploaded to it, what are some of the considerations for that website, do you think? Like compared to a website that doesn't have videos? What would a website with videos need? Mm-hmm. Okay. An upload button. I mean, you know what? Fair enough. And you can get that specific. The amount of space, Ada says. That's a good one. That's a good one. So, but also like the server speed, right? Videos are very like difficult to download. It's a lot. It's like having hundreds of images every single second. So this is like quite a difficult thing to support. Sorry, Ada, I did see you were about to talk. I don't know if I accidentally interrupted you, so sorry about that. But yeah, feel free to use your mic as well. Okay, so I'll give you some examples of what we would have to be thinking about immediately, right? So when they just say this, These are some of the ones that I came up with, and we'd already discussed some of these. So when the product owner says, we want you to be able to upload videos to our site, we have to be thinking already, okay, we're going to need a very fast, scalable server, right? So yeah, it'll take up, the videos will take up a lot of space. The server has to be very fast to distribute those videos to all the users. We have to be able to support multiple resolutions, right? Like SD and HD, because also different screen sizes are quite an important consideration. We should ask them about like what video formats they want to support, right? Because there's a bunch of different video formats and we might not necessarily want functionality for all of them. And also we can already tell them that this website will be super expensive because hosting videos is expensive. Okay, so that's like instant, right? It's just from that singular sentence, you've already got all of these requirements. So let's see what the product owner says next, and we'll perform this process again so we can even get a better idea. So the product owner now says your friends must be able to view them. So this originally they said, we want you to be able to upload videos to our site. And now they say your friends must be able to view them. So what are we thinking now?
I mean, is it just this person's friends or can it be anyone?
Well, yeah, exactly. So we need to now define the term friends. And would that be as like contrary to subscribers? Exactly. We would now need a place. We would have to set up this whole following thing. We would have to, you know, figure out how to match people to their friends. How do you add friends? How do you remove friends? Because he says your friends must be able to view them, but they don't say whether everyone else can as well. You know, like what sort of privacy things do we need to manage for this system? So some of the ones that I was thinking about immediately after just saying that, we now need a relational database. We need what would be called dynamic web design because the pages will be constantly changing. Like whereas before we would just, you know, you would just visit a page and maybe just have a list of all the videos that have been uploaded. Now we need it to go, you access a page, but only videos that you have access to watching must be displayed to you. And then obviously there's this question of like, what does this person mean friend, right? And that is another job of the requirements analyst because the product owner will be saying things. And basically as a requirements analyst, you would have to be able to cut through all of that and figure out what the important questions are, right? So one of the important questions to establish for the functionality of this site would be what a friend is. And then they say on mobile devices and the website. So now we want you to be able to upload videos to our site. Your friends must be able to view them on mobile devices and the website. So now what are we thinking? An app and a website? Well, exactly. And I mean, is it even that simple? What do you mean app?
Yeah, because you can still view the website on your phone, so it defeats the purpose.
Well, yeah, that's true. So you could technically say we don't even need an app to say that. We could have like a mobile friendly website. That's true. What if we did want an app? Let's say we do want an app for mobile devices. What considerations would be involved there?
What's the difference between apps and websites? I guess apps are just more convenient than going into the actual website.
Yeah, so in the one is designed in a more system specific way. So your app, like a larger portion of your app will be run on your device. And yeah, I mean, in principle, like your web browser on your phone is a specific app, right? Which you would use to access websites. Data usage, I mean, yeah, fair enough. You might have to consider stuff like that, phone specific things. But I mean, there's a very obvious one, like what's the divide that exists in phone apps? If someone tells me that they want an application that can work on all phones, what immediate problem presents itself?
The operating software.
Exactly, right? We've got like this huge divide between Samsung or like Android phones and iOS phones, right? This is like a huge deal. You have to develop 2 apps actually. So some of the things immediately just after this one little bit, half a sentence, what that adds is, okay, you now need what's called a web backend for iOS and Android applications. So what you would want in this situation is people could download the web app to the app to their phones, but all of the apps must still communicate with the same database, right? Like if someone uploads a video on Android, you must still be able to watch that video on iOS, right? So you need one central server that can communicate with all of your different apps. Quite a difficult problem. This would also require development. So now we can pin down languages. This would require us to develop in Swift, which Swift is what they use to develop iOS apps for Apple phones, for iPhones and stuff. Java to develop Android apps. Nowadays, people would use something called Kotlin as well. But yeah, Java basically. And then some web frameworks. So there's quite a few. I'll just name some. ASP.NET is one that is made for C#. So you should definitely recognize, you should know this one. You shouldn't recognize it yet because we haven't got into that chapter. But ASP.NET is C# based and you can use it to make sort of websites. Node is, I don't know if any of you have heard of JavaScript. Node is with JavaScript, and Django is for Python. Django is what they built Instagram in. And YouTube actually is also Django. Okay, but anyway, so just from these, what I would want you to see is that just from these 2 sentences, a technical analyst could expand to all of these things and more, right? Like you named storage, following tab, data usage, the amount of space, and upload button, all of those things would also fall under these requirements. The point is though, this is like quite a difficult thing to do, right? Taking these abstract ideas and making them technical and getting to a point where we can go, okay, this is possible, and this is how we would do it. Okay, so that's what requirements analysis is. There's one further thing that we have to discuss on requirements analysis, and that's this distinction between functional and non-functional requirements. I don't think we need to spend too much time on this because it's a pretty easy concept to grasp just by their names, okay? Like functional requirements are, they're functional, and non-functional requirements are non-functional, and you'll see that now when we go through a few examples of each. So let's just display their formal definitions quick. So functional requirements, specifics regarding what the system should be able to do. Okay, hearing the word functional, you should be thinking along that line anyway. So the name kind of gives it away. Okay, so what do we mean when we say functional? Like when the product owner told us that they wanted the application to be able to add friends. Okay, the ability to add a friend, like clicking a button that will add someone as your friend, like sending a request, acknowledging the request, all of these kinds of things would be functional requirements for that app. Being able to upload a video, being able to view a video, all of these kinds of things would be functional requirements for the application. It's basically anything that it can do that is directly related to how a user uses it. Okay, like why are we making this system? What tasks what tasks does it perform? These are the functional requirements. And you might say, oh, well, is that not all of the application? And in fact, no, it's not. So the other side of things is non-functional requirements. And these are specifically quality requirements that the system should meet. An easy trick that we were taught at WITS on how to memorize non-functional requirements is it's basically anything that ends in ity, okay, I-T-Y. So, and I can give you an example of this, okay? So let's say we are thinking about that site that can upload videos, okay? Being able to upload a video is a functional requirement, okay? But hopefully you guys can see if there are multiple ways I could program the ability to upload a video. Okay, there are multiple ways I could program the ability to upload a video. I could say you upload it and everyone can view it, or it's uploaded and it's kept in a public server. So you can access the video through a link. Okay, we could say that. However, the other way I could do it is I could upload it, encrypt it, and make it so that it's not publicly accessible. Okay, so the difference between those two things is non-functional. In both cases, you can upload a video. The difference is in security. Okay, and notice security, it ends in ity. It is a non-functional requirement. Other non-functional requirements might be scalability, maintainability, testability, all of these kinds of ity words. Okay, and yeah, there are many, but in general, if you just recall that it's quality requirements about the system. So it's pretty easy to distinguish between a functional and non-functional requirements. I hope you guys can agree. And yeah, so we can give a few, we'll give a few examples in the quiz. Yeah, it means they also specify some at the top of page 67. So scalability, security, and yeah, reliability. That's one that we hadn't named. Okay, reliability. That's a good one as well, right? Like we could say, oh, you can upload a video, but occasionally the system will break, right? So you can log on and you can upload a video, but like it'll only work, I don't know, once every hour or something. Alternatively, we could program a system where you can upload a video and 24/7, it's always up, it always works. The difference there is reliability. It's a non-functional requirement because in both cases you can upload videos. The difference is the reliability of the system. Okay, so hopefully you can see how those non-functional requirements differ from functional requirements. Okay, onwards and upwards. The next thing is design. Okay, we are going to be discussing design in a specific way. So there are a lot of components to design in an application. Can you guys think of what you would want to consider in this design phase, bearing in mind that it's also technical. It's also technical design. Anyone? Aesthetics, yeah. So aesthetics, UI design, we would call it user interface design, or UX design, user experience design. That would fall under design, 100%. So yeah, it is just the aesthetics of the site. And on a more technical level, we could say that actually planning how you're going to develop it, right? Actually planning how you're going to develop it. Designing the architecture is an important component of this. Okay, so we're going to list off the different types of design, but I do want to discuss the different architectures that we can use. Actually, yeah, we'll do one of these architectures just before we take a break, and then we'll come back and do the other. Okay, so one important aspect of design is deciding on an architecture for your website. Okay, you might not have heard the word architecture related to software development before. Well, then, you know, congratulations, this is a first. The architecture of a site is the blueprint of the system, and you can hopefully remember that by its relation to the word architecture in how we usually use it, right? The blueprints of a building. Who would give you the blueprint of the building? An architect. Who would give you a blueprint for a system? Like a software system, it would be a software architect. Okay, so what would the architect decide on? So they basically decide on how the different components of the system communicate with each other, right? So we have this architecture on the left here is what we would call an event-driven architecture. So we did have that lecture on events. And you don't really have to understand events necessarily to understand an event-driven architecture. But the main thing about this is that if you decided on using an event-driven architecture, everything would be implemented using events, right? Everything would be implemented using events. So what would that mean? For example, you would have a bunch of things that can a bunch of events that can occur. So we discussed the example of being able to upload a video. When a video is uploaded, all of the other components of your system would be contacted. Okay. And how that would occur is the uploaded video would, the part of the system that uploaded the video would shout basically that it's uploaded a video and throw that onto an event bus. So it'll communicate that that event had occurred, right? So it'd say, I uploaded a video. And that little communication would move down this bus, and everything that's concerned with looking for that particular event will be watching the bus. And as soon as it sees that a event has occurred, like a video has been uploaded or a user has joined the site, as soon as the relevant component sees that that event has occurred, it will then act. Okay, and it works. So basically, it's like take the concept of a normal event that we have learned, where something happens, it shouts. There's a subscriber listening for that event to occur, and it does something else when it sees that event has occurred. Take that idea and just assume that the whole system is programmed in that way. And then you would have been using an event-driven architecture. So every component, every single button would be programmed using events. Like when you mouse over it, it changes color a little bit. That would be done with an event. When you upload a video, it'll be done with an event. So basically what the architecture is allowing you to do is, like, say you have a whole team of developers working and you say, okay, guys, we're going to agree that we're using an event-driven architecture for this system. So then everything you program, everything you develop would use that architecture. Okay. You don't have to understand on a super, but it's basically like an agreement of how the system would be programmed. You don't have to understand on a super technical level. I did want to tell you guys, like give you guys some examples of what architectures are, but the primary thing is for you to remember that this is the blueprint of the system. Okay, so it's like the way all the developers have agreed that the system is going to be designed in this way. And when you actually build it, you make sure you follow the rules outlined in the blueprint. When you add something, it must be added in an event if you're using an event-driven architecture. This alternative architecture is much more common. And so we'll explore some sites and just what exactly this architecture does. It also makes a lot more sense. So we'll start discussing this one, but after the break, I think, because yeah, we have been going for 45 minutes. So yeah, let's do a 10-minute break or 9-minute break. We'll come back at 15:55. Okay, and if you guys have any questions on the break, feel free to ask. I think I am, okay, I can actually mark the register on my phone for the other people who joined. So it was Tariq and Ada. Yeah, fire away. About the extra course. Yeah, go ahead. I don't know what I'd be able to answer. I'm not personally running it, but yeah, I'll see if I can answer. If I can't, then I'll pass on the question to someone who can. Let me mark off this register quickly. So Tariq and you can ask through your mic as well if it's faster. You don't have to type. I mean, we're still learning C#. Isn't the course a bit advanced for us? No, I don't think so. And I think they do guide you through it quite nicely. Have you checked out their course outline? You should. So it's like this, the sessions are long, hey? They are very long and they seem to go very in depth, but basically, no, I think you guys would cope. It's not, I don't think it would be too bad. And you'll notice that a lot of similar things come up, like in game design specifically, you'll be using a lot of events. You guys sort of know what a method is and what a class is. And so it would just reinforce your ideas of what those things are. Remember that the language is just a tool, really. Like once you have the theoretical knowledge, you can always apply it in these different areas. Wow, it's taking very long for my phone to open the register. But yeah, there's like a little PDF or something that they have on the site that lists, I think there's like 11 classes, and you literally just make a game in Unreal. So, but they guide you through all the steps, obviously. They don't just leave you. But then also, I mean, keep in mind your other commitments, hey, because it also depends. You guys in particular have been pretty, yeah, well, this is the thing. I would say, so this is probably a better place to start, the course you're doing now. But if you have the time and like you're not too pressured by school come August, then yeah, I would consider doing it, especially if that's something that you're interested in doing in the future. I would say, yeah, doing both at the same time is not a bad plan. But remember, I mean, that's even a larger commitment than these weekly lectures, and they're not gonna be able to handle delays and stuff because they're on like a very fixed schedule. So make sure, like, I think wait until your school makes some kind of announcement or something so you know what's happening with school more, because obviously you must prioritize that. And now it opens instantly. Okay, so Tariq is here, so let me mark you. Wow. Google Sheets doesn't work very well on phones. Okay, Tariq is 4. Okay, no, that's impossible. I'll just mark you guys on the register at the end. Oh, it seems like one person went, so have to see. Do both at the same, yeah, I guess. I want to do that course, but there's so much going on in terms of school. Yeah, I mean, remember the course will probably happen again. You don't have to rush too much. You guys have plenty of, I mean, in like the long term, you have plenty of time. Obviously, currently you don't have much time. So rather focus on the commitments you've already made for now, I think. And you can always, but yeah, I mean, if school does close, then 100% go for it because you'll be bored otherwise. But if not, then I think focus on school because it seems like you guys are already a bit overworked. So I don't want you to. And I think that course will probably be a success because obviously a lot of people are interested in learning that kind of thing at the moment. So they're almost certainly going to have it next year as well. So you can always do it then. And it seems like next year will probably be a little bit more relaxed than this year, I think, because this year has been quite crazy for everyone. Yeah. But then I imagine if they did acknowledge that schools needed to be reclosed, they would also acknowledge that things need to be pushed back a little bit. And so your schedule might not be as hectic as it is currently, even if you are doing online classes and stuff. Okay, Ada disappeared. Maybe it's her internet connection, I'm not sure. I think so. Particularly because the teachers' unions are saying that they should. But obviously it's a very difficult thing to predict. Yeah. I think it's very easy to argue that going to school at the moment isn't necessarily so safe. And yeah, the bigger issue, I think, is whether or not private schools can handle it. Because many parents will not be happy with the idea of paying an extra year of very expensive school fees. And also the IEB, obviously, if there's like an international examination, it's very difficult to just reschedule on a country by country basis. So yeah, I'd say that's one big problem that those schools will have to deal with. But public schools, I think, almost certainly, it just makes more sense to close if you're able to. Like Kenya, I know already did it. They already just said that the school year is cancelled basically, and it will be picked up again next year. And I think that is the more sensible way of handling things. Keeps the quality of education good and stuff. Anyway, let's not think about those things. We'll just figure out when they do. Let's focus on the design stage of the application lifecycle. Okay, so on the right here, we have what's called a model view controller architecture. This is probably a fairly good, this is probably the most common architecture used in web development. So wait, actually, one of you name a website, your favorite website or your favorite app. Just type it in the chat. What name on any website? What's the most popular? I don't know. Name one. YouTube. Okay, yeah. So YouTube, fantastic. YouTube would use an event-driven architecture for a lot of things because of the publisher-subscriber model. But I know it was made in Django, and so it certainly uses a model view controller architecture because this is almost prescribed in Django. It's interesting because they must have a pretty crazy system going on to be able to support so much stuff. But yeah, it's made in Django, so that would be an example of a site that uses MVC architecture. Anyway, so model view controller, another big site that uses this would be Instagram. So, but anyway, so what does the model view controller architecture do? Okay, the view, what's nice is that it's split into these three components very clearly, and the name of each component kind of gives away what it does. So the view is what the user sees. Okay, when you access the site, there's some template defining what goes where, right? Like think about YouTube where you open up the website, okay, and they have a place that will display a video to you, right? So there'll be a video title in a specific place. The video's length will be in a specific place. The thumbnail will be in a particular place, right? There's a template, but for every single person using the site, a different video will be displayed, right? Or pretty much everyone will get a different video or a different order of videos, okay? So there's a strict template defining how the videos are displayed, and all the system has to do really is decide what user sees what, right? Which videos go to which user, okay? And so an MVC architecture works particularly well for that. So the view will define that template, right? It'll say title goes here, thumbnail goes here, number of views goes here, okay? The controller is what will pass the information to the template. So the controller will go, oh, here's a title, here's a thumbnail, here's the views for a specific video. And the controller will pass as many as it needs. Okay. The model is what actually communicates with the database. So a big problem in historical development was that there's a lot of different ways to create databases, and all of them you need to communicate with the database in slightly different ways. The reason, and this is part of the reason why MVC became so popular, is because you can define a model that sort of hides away the database. So whatever database you're using, it doesn't matter because the model will translate them all into the same thing, okay, into the same data. So it will, yeah, so basically it defines the format of your data, okay? So basically you have a thing that represents the data. The controller passes data to specific views, because remember, every single user, when they log on to YouTube, they'll get that same template, like the video is displayed in the same way. It has a thumbnail, the title, and the views. The controller will control which data goes to which user, right? So all the users have the same template, but the controller will give different data to each one. And the model is what translates the data from the database and so defines a set template that the controller can use. And that's an MVC architecture. You'll actually see it in action now because our horrible little website that we're going to be editing, bfmta.herokuapp.com, the Rickroll website, this website is also programmed using an MVC architecture. Okay, it is probably the ugliest website of all time, this one that we made, but trust me, you can make very nice websites using a model view controller architecture as well. They don't have to be gross. All right, so that was just an example of two architectures. You won't be, I don't think you'll be tested on them too much, but do know what MVC stands for. So do know what a model view, what the MV and C in model view controller stands for. So yeah. But if you know that, I think you'll be pretty good. Okay, and these are just examples of what architectures were. So I wanted you to see the more technical side rather than just learning that it's the technical blueprints of the system. Okay. Next, we have user experience design. We already discussed that. That's aesthetics. Okay. How will the user experience the site? I mean, it is a little bit more technical because obviously you have to be able to click buttons and stuff, right? And buttons have to fade in and fade out. And actually, like, these things can be quite difficult to program. But in general, especially in the design stage, this is strictly aesthetic. You're designing the site, what buttons go where, what pages navigate to what other pages is the other thing. So it is more functional than just aesthetics. Because when you click a certain button, you have to actually go to a certain page. And that should be streamlined in a nice way, right? Like when you click the login button, you should be taken to the login page. That's a part of the user experience. So it is like a design choice, but you know, there's a technical aspect to it as well. Okay, and lastly, we will also just do general planning under this design stage. So deciding on what languages we're using, what services we're using, and what frameworks we're using. So I think we will discuss in more detail this definition of services and frameworks. I think the textbook saves that discussion for chapter 4. So we will come back to these two ideas and you'll have a more technical understanding of that. Hopefully you guys, actually not hopefully, you know what languages are but by now, right? You can name a few: Python, Java, C#, C++, C, all of these are languages. Okay. Cool. So after that, we've done requirements analysis. We've designed the application. The next thing is to actually develop it, right? This is the development stage of the application lifecycle. It's what we've been discussing for long, right? This is where you do all the programming and all the actual work. But remember that there's also there's a few other jobs here, okay, that are important. So it's not just software developers. That's the main thing that happens here. But there is also database administrators, right? Someone has to make your database. There's also technical writers. So they'll make manuals and sort of documents how the site is coming along. And then there are content developers. So that is, I don't know why they call them that, but you can basically think about that as just a content creator. Okay, so obviously the site can't just be empty, right? So as you develop it, you'll need to fill it with actual content, even just so that you can test and use it, right? Because having an empty site is somewhat useless, obviously. Okay, so that's other things that happen at the development stage, but the main thing here is it's programming. Okay, it's pretty intuitive what the development stage includes. Okay, so we're gonna jump right through that. We've now got a develop, or like while we're developing an application, we also have to think about testing. So this is the fourth stage of the application lifecycle. This is the one that we're gonna go most in depth on. This is about as theoretical, this stage is like as theoretical as we get. And I am gonna do a little bit of a programming thing now, just so that you guys can sort of learn what these different things mean. But before that, so there are different ways of discussing testing, and the textbook recommends two of them in particular. So I prefer the second way. So they define approaches to testing and levels of testing. Okay, approaches to testing and levels of testing. So the approaches to testing are split into just two categories, and they're pretty easy to remember by how they're named. Some people were, we'll see. I think you guys will get it. So the two approaches that they describe for testing, I don't like discussing testing in this way, but I mean, if you do, that's great. The two of them are black box testing and white box testing. Okay, black box testing and white box testing. The difference is pretty easy to understand. So when we're doing black box testing, you picture yourself as a user and you just use the application. But the idea is that you don't know the inner workings of the system. So if you guys know what a black box is in computer science, it's generally like you input something and something is output. You don't know how the internals work. It's a pretty common idea. Where the term comes from, you know what a black box is on an airplane, where I think someone mentioned that funnily enough, black boxes on airplanes are usually orange or something, but whatever, they're called black boxes because it's recording something, and so you can input things into it and it gives you something back, but no one really knows how the internals of the thing works and no one really cares, right? You don't care about how it works. You just care about what it does and what it's recorded, like what you input and what is output, okay? So black box testing, you treat the system as if you don't know how it was programmed, okay? So as an example, you guys have heard of beta testing in video games, right? So you give the game to a bunch of users, right? The users don't know how the game was made, right? The users don't know how to develop games, right? They don't know how everything's programmed. They don't know whether you're using an event architecture or a model view controller architecture. They know nothing about how the site is developed. They just use it. And then the user kind of just tells you at the end, right? So they use your game or whatever, your system, for a couple of hours, and they don't know how it works really, but they'll come back to you at the end of that couple of hours and say, I liked it, or I didn't like it, or this broke, or there was a bug or something, right? Something unexpected happened. So that's black box testing, because the user is just inputting things and stuff is happening, but they don't know how it was developed. So they're not, the system itself is a black box to them, right? They don't understand how it works. Everything's hidden from them, okay? Yeah, a general view without a technical understanding of the site. Actually, if we contrast this to white box testing, it might make more sense. In white box testing, you're the developer of the system, right? You know how the system was created. You know how to break it, okay? So in white box testing, you use your knowledge of the system to write tests and to test the system in ways that are more meaningful, okay? So this is basically saying in black box testing, we don't care about how the system was developed. We're just testing whether or not it does what we expect. In white box testing, we know how the system was developed, and so we can test in like a more specific way, okay? They call these the two approaches to testing. Yeah, I suppose you could say that, exactly. So like if you know in particular that when you developed the game, there was a specific feature, like when you walked to a certain place that you had to, when you were programming it, you handled it in a funny way or something, right? Like when you walked to the edge of the world, you created some if statements, and you're a bit like, you're unsure of whether or not you programmed that in a clever way. So you actually go in the game to that place in the world, or you write like a specific piece of code that'll do it for you, and you see if it breaks, right? The reason you knew to do that is because you knew how the system was developed. Whereas in black box testing, you wouldn't know that. The user would just be stumbling around and maybe they just find out that that was broken. Okay, so the difference is in how much you know about the system, and more importantly, how much you use your knowledge of the system. In black box testing, we don't have knowledge of the technical knowledge of the system. In white box testing, we do. Okay, I don't necessarily like this way of discussing testing. Don't think it's super meaningful. I like the next way more. But hopefully you can see what it is these things mean at least, right? Yeah. Okay, so yeah, is any questions? I think it's pretty, I hope we are okay. I'll make sure to give like we'll include some of this stuff in a little quiz as well. So what's the best form of testing? There isn't really a best, and this is partially why I don't like this way of describing testing. Right, because obviously black box testing is very important because the users at the end of the day are the people who are using your system, right? So they need to like it. So you need to do black box testing, because if you don't, you'll never know whether users are actually using it in an expected way. But of course, as a developer, while you're developing, you need to be doing white box testing because the code needs to work consistently and it needs to work as expected. So I think the next way of discussing testing is more meaningful. What's more important on this stage is to just know the difference between black box and white box. Yeah, a mix of both. And that's why I don't like splitting it like this, because it's not as meaningful. But yeah, you would do a mix of both when developing an app, 100%, Sadi. This way, I think, is a better way of discussing testing, the levels of testing. Okay, so there are 5 levels to testing. I did want to write a unit test, but I do want to sort of, we will write a unit test because I do want to get us some practical experience with testing, but we're going to move through it pretty quickly today, just so that we can, so it's Ada, my Wi-Fi is acting up, so I'll watch the YouTube video. That's so unfortunate that her Wi-Fi is bad. Okay, but it's okay. Yeah, we must just try to figure that out, I guess. So yeah, anyway, sorry about that, guys. So levels of testing. Cool, we will program a unit test next week, but for now, we're just gonna get through all this theoretical stuff so we can do the fun stuff next week. All right, so unit testing, that is testing the small parts of the code, individual units of code. These can be methods, classes. The point is it's a small thing, a specific problem that you are testing. So the example that we will do is, let's say we have a bank account, okay? And the bank accounts can, obviously you can deposit money into the account and you can withdraw money from the account. So a unit test, for example, would be testing whether or not we can properly withdraw from the account, okay? So we go, can I withdraw money? When I withdraw money, does everything work as I expect? That would be a unit test, okay? And then another unit test, we could write another unit test to test whether when I deposit money into the account, that it works as I expect, okay? So those would be 2 little unit tests that we could write. Okay, so does withdrawing money work and does depositing money work? And I think let's carry this this example through so that you can see all the other options. Okay, so unit testing is when we test those small units of code independently. Okay, we don't care if withdrawing money works after we deposit money, or if depositing money works after we withdraw money. We don't care about that yet. We're caring about the individual methods, right? So you can picture that these would be different methods, and we test them individually. Okay. We then move to the next stage of testing called integration testing. So we might have tested that, okay, when I deposit money, it works. When I withdraw money, it works. Okay. But now, obviously, when we're actually creating the system, the banking system, those components have to be integrated. They have to work together, right? You can't just have a bank account that withdraws money. That wouldn't be useful. You can't just have a bank account that can deposit money. That wouldn't be useful. Both of these things need to work, okay? So after we've tested that they work independently, we can join them together. But the problem is, if they're working independently, after we join them together, they still might break. So I'll give you an example of how that could happen. Let's say we have a system where, okay, I deposit money and it works as expected. It increments my accounts, nothing weird happens, okay? I have as a separate test, I also tested if I withdraw money, it subtracts the money from my accounts as expected. It, gives me the money in the correct way. Everything works as I hope. I then merge these things together. So I want to now deposit money and then withdraw money, okay? So individually, these components were working. But let's say now when I integrate them, when we deposit money, it takes just slightly too long. Let's say it takes 5 minutes for my account to be incremented. And so then when I say deposit 500 Rand and try to withdraw 500 Rand immediately after, it doesn't work. So the two units worked individually, but now that I tried to join them together, it's broken. Okay, so that's why we have to test at both stages, because we need to find out where this break happened, right? So we test them individually, and then when we integrate the units, we test them together again in integration testing. Okay. Now you can picture in the real world, we would have a whole bunch of different units, right? And different integrations, right? Like that system that I just described with withdrawing and depositing, that could be separate from another system that increments your account with interest or something like that, or handles credit or handles savings accounts, right? There might be a whole bunch of different things at a bank, okay? So our integration tests might work, but then on another level, after this entire system is complete and everything is on the correct website and all the applications are communicating to each other and the database is working, we then have to test again, okay? Because if even all of our integrations were working, it might be that on the entire system level, something is still broken, okay, when we actually go into production or something like that. Okay, so we've now got 3 levels of testing. And you might say, okay, well, now I've tested all the individual parts. When I mix the individual parts together, I test them again to make sure that the integration didn't break anything. And then once I've completed the entire system, I test the system again, just to make sure that the whole system works. Okay, so you might say, okay, that's all, right? We can stop there. And this is what I actually like about defining testing in this way, is that it doesn't stop there. There are still 2 more. Okay? And you might think like, wow, I mean, what else is there, right? The next level is what we call acceptance testing. So they merge this in. You would think that actually acceptance testing maybe isn't the same as these other testing, right? Like this testing, the unit testing, integration testing, system testing was looking for broken parts of the code. Acceptance testing is where we finally go, right? We had our product owner and we had all these other people, all of our users. We actually go to the users, we go to the product owners, we go to people who will be interacting with and paying for the system, and we ask them, do you like this? Does the system work as you expect? And that's acceptance testing. When we just go to the people and we ask them like, is this system working correctly? Are you able to use it? Is it doing what you expect? Okay. And so if they go yes, then acceptance testing is passed. If they like the system, if the system is usable. Okay. And then the last stage of testing it has to do with maintenance. It still falls under the testing level of the application lifecycle. It's called regression testing. So basically we might have a fully working system that all the users like. So we passed all 4 of these stages of testing, okay? But then one day, a new version of C# comes out, okay? So let's say we were using version 4.3 and version 4.4 of C# came out, and we have to upgrade the system. So we then upgrade the system. Okay. Now, you have to, when you do that upgrade, you have to re-perform all of the important tests that that upgrade could affect. Okay. Any part of your code that was using 4.3 now has to be tested. Okay. Because as you upgrade or maintain a specific part of the system, related parts of the system might break. So you have to retest all of these different parts. Okay. So like as you upgrade and improve things, you continually have to test. These testing things do not happen once. You have to do them again and again and again as you develop the application. Okay. So that's testing. And yeah, I prefer discussing in this levels of testing, but know that there are these two different ways that the MTA discusses testing. There were the approaches to testing, which was black box versus white box. And then there are these 5 levels of testing. Okay. So unit testing, test everything independently, all the small parts. Integration testing, we mix the small parts together. Do they still work? System testing, we've now got the entire system complete. Is it working as a whole? Is it ready to be like given to users? Are we ready to test this in the real world? Acceptance testing, okay, we now take it to the customers. We take it to the product owner, the person who asked us to develop this. We ask them if they like it. And then regression testing is like this continual process of, as we develop and upgrade the site, we have to retest components that could have broken. Yeah, in a way. So acceptance testing, remember we said black box testing, like beta testing and alpha testing would be black box testing because it's the users using it. Beta testing and alpha testing would be a part of acceptance testing in this case. Okay, like acceptance testing would cover most black box testing things. And like unit tests are definitely white box testing because we're testing particular parts of the code that we think could break. Okay, and we're testing them as developers, so we have knowledge of the system. So yeah, that's correct, Hadi. But consider these separate in your head, really. Like the approaches to testing, like white box versus black box, that's one way to discuss testing. And another way of discussing testing is the levels of testing, like these 5 different levels. But they're sort of used independently of each other. Okay. But yeah, good question. All right, I know it's a lot of new words and we did go through them pretty quickly, but I don't want to spend like, you know, many lectures going through each one because I think the theoretical stuff, we want to get over it, especially since we're just coming back now. I want to focus on doing fun stuff instead, like developing that website. So yeah, we'll come back to this kind of stuff. Or at least I'll include it in the thing. In the little quizzes and stuff and the examples that we do. Okay, so after test, okay, so white box and black box is a thing on its own. Yeah, exactly. So we would say if someone's referring to different approaches to testing, then they'll usually be talking about white box versus black box. If they're referring to levels of testing, then they're referring to unit testing, integration testing, system testing, acceptance testing, and regression testing. Okay. But yeah, just remember what each of the terms mean like on their own, and remember that yeah, they're separate. They're like independent considerations. Yeah, they discuss them they're discussed in separate contexts, 100%. But they are still both in the same level of the application lifecycle or phase. Sorry. So we call these phases. Requirements analysis, design, development, testing, maintenance are the 5 phases of the application lifecycle. Okay. The last phase is maintenance, and as who was it who we asked? It was Logan, right? Yeah, as Logan said, in maintenance we maintain the site. That is pretty much what you need to know. So, but however, there are some technicalities. So maintenance is where we do all the updates and upgrades and all the bug fixes and stuff. All of that happens under maintenance. Also remember that while we're maintaining the site, it is a part of testing. But while we're maintaining the site, we're continually performing regression testing, right? Anyway, but maintenance, yeah, we're doing all the upgrades, all the updates, but there are a few other considerations. So number 1, we manage releases under the maintenance phase. So if you've ever seen a website have like version 4.0.1, version 4.1.2, all of those kinds of things, that is done by a person called the release manager, and it's done under the maintenance phase of the application lifecycle. Okay. Another important part of maintenance that you must remember is support staff. So like when you phone Standard Bank and someone answers the phone and they're, you know, really like probably a person with quite a depressed voice and they're saying, oh, how can I help you? That person is performing maintenance. They are called technical support staff, and that is under the maintenance phase. Okay, support, technical support for your users is under maintenance. Okay, so those are two extra things to remember that you might not have included under the maintenance part of maintenance phase. So release management, updating and upgrades, and technical support staff are the important parts of this maintenance phase. Okay. And that brings us to the end of the application lifecycle. Not too bad. However, there is one other thing that I just want to emphasize, guys. And then we have to discuss something, and then we can stop. But quickly, I'm going to highlight this little arrow in red. Okay, you see that little arrow that's highlighted in red? It's in a blue box. It's got a green arrow pointing at it. Don't know if I've emphasized it enough for you guys yet. That arrow there, you see it is making this a cycle, and we use the word cycle, right? So this is a continual process, okay? Like it doesn't stop. So when you finish this, so once you've developed the app entirely, you've tested it, everything's working, everyone's happy with it, you're now maintaining and performing updates. When you perform an update, you go back, you start again, because when, like, let's say you've developed the app, everything's working, you're Google now, okay? Like you're a very profitable tech company. The boss comes back to you and they say, look, I'm not happy with this one part of the site. I want you to update it, right? When they tell you that, you go back to the first problem, right? When they speak, they're not speaking technically. They know that the site isn't working how they want to, but they'll just tell you some vague thing like fix it in this way, make the button better or something. You then have to translate that into technical requirements. You have to design how you'll include that in the site. You have to actually develop it. You have to test it and you have to maintain it. Okay, so it's a cycle. It continues on for every single update, every single upgrade. It's always requirements analysis, design, development, testing, maintenance. Okay, so it is a cycle. Okay, so it goes on and on and on. Right, there are other ways of displaying it, but you can see it's always in a so it never really ends. Yeah, exactly. You have to continually develop, and yeah, so what they call it is agile development. Okay, so it's like this feedback loop. You develop something, you give it to users, they give you feedback, you develop, you give it back, they give you feedback, you develop, give it back, and it goes on this continual cycle. Okay, and yeah, there's other ways of displaying it. Obviously, you must remember the one in the C# book. I'm just showing you that there are some different ways of saying it, but you can see they're always pretty familiar, right? Meet and plan. That's kind of like the requirements phase. Design, cool. Coding and testing, that's our development phase. Release, feedback, they included testing and developing under one phase, you know, whatever. They included release management as separate, and they don't call it maintenance. Obviously, there's updates happening somewhere here. And yeah, feedback is getting feedback from users. We sort of include that under like acceptance testing. So there's different ways of discussing it. Obviously, we must learn the way that the MTA will be testing. But yeah, the point is it's a cycle. Okay, cool. So we would next go and start and actually apply. So what we would do is you guys would give me some requirements. So our horrible website that rickrolls people, you would give me some requirements of what you want to add to the site, and we'll go through the entire application lifecycle with the requirements you specify and actually add them to the site. Okay, but we'll do that next week because we're almost out of time. But what I wanted to show you guys, there's one last thing before we get going. We should be able to do it quick. So there is a very cool website, guys, that I'll be referencing quite frequently. Okay. So it's called codewars.com, codewars.com, all right? And when you visit that website, when you visit codewars.com, you'll come to this homepage, all right? This is their homepage. You'll see that they have a lot of different languages. The sixth one here is C#, okay? So you go click on C#, and it's gonna give you this little challenge, all right? This little challenge here, okay? I want you so this is called the initiation challenge. After you've solved the challenge, you'll be able to create an account and log in, okay? Just before we have our next lecture, I want you guys to solve the initiation challenge. I think some of you will find it quite easy. Maybe others who weren't paying attention when we were discussing operators might be a little bit confused. But I think if you read each line, so just read every single word in each line, even if it's a bit scary, just read each word and you should come to a pretty sensible conclusion, I think. Okay. After you submit this, after you solve this challenge, you'll be able to create an account and you'll be able to log in, and you'll see that on the website. So I've obviously solved the challenge already. I'm just gonna log into my account. I'm just gonna show you what goes on here, all right? So they have a whole bunch of challenges that they call katas. I don't know if you've ever done like martial arts or something in your life, like karate or something, but they have katas as well. So there's like different forms, different fighting styles, different like patterns that you learn when practicing a martial art. And that's kind of what these katas are. They're little programming challenges. Each one teaches you a different thing, okay? Each one teaches you a different thing, and they're each at a different level. So they have 8 levels here. Each level is called a Q or Q. So there's 8Q down to 1Q. 8Q is the easiest. And basically, I want you to create that account. I want you to solve the initiation challenge. And each week, I'm going to recommend a different kata for us to do. Okay. And that kata will be in somehow relevant to what we did in the lecture. Okay. And we'll move through and get some more and more difficult katas, hopefully. Although they are like the 1Q challenges, like actually already from like 4Q, I start having difficulties. So we probably won't get too far in, but like because the challenges do get very difficult. But if we can progress to like 6Q by the end of the course or something, that would be very cool. Okay. Anyway, so we'll do, yeah, but for this first week, all I want you to do is solve the initiation challenge and create an account. Okay. Yeah, precisely. So Taddy has given you a little hint there. Please, Taddy, don't say more. And remember, guys, so if you log in and create a sign up or whatever, you're welcome to do some kata by yourself if you want. And yeah, just remember that obviously a lot of these puzzles you might be able to find answers to or whatever, but remember that a good puzzle can only be solved once, guys. If you spoil the puzzle, you have to wait until you find another good puzzle before you can get another one, right? Like, so don't spoil puzzles for yourself or for your friends. Okay, so yeah, maybe if you feel like it, work through a few kata, but I will, after each lecture, I'll recommend a kata relevant to what we've learned. So you guys can get some actual programming experience from each lecture as well. Okay. So we will be doing that from now on. But for this week, the only task is solve the initiation challenge and create yourself an account on CodeWars. All right. And that is it for today. If you have any questions, I'll stay on the call for a little bit longer as well. Let me stop sharing my screen. Cool. And thanks for coming to those of you who did. We're going to have to make a lot of phone calls to find out why some people still aren't making it. Yeah, so you can run tests as much as you like. If you click on a kata in the bottom right, it'll say attempt. Don't click that one yet. You can say like test. So you can test it as much as you like. And yeah, it works pretty, the initiation I meant. Yeah. I don't think they're going to lock you out. They won't lock you out. That would be very mean. Okay, but you've already solved it, right, Taddy, you said? Yeah, and actually based on your hints, I can tell you already solved it. Yeah. Okay, cool. So that's great. I'm glad you managed. But guys, don't worry. I'm like, obviously we haven't done too many. Okay, great. That's fantastic though. That's good. Yeah, some people were a bit confused, but I'm glad that you guys managed it so easily. And next week I'll recommend a kata that's obviously the initiation challenge is very easy, obviously. But the katas do get more difficult, and I'll recommend one each week. But it'll be quite fun, I think, to work through and maybe share our solutions if we have different ways of approaching problems. Okay. Yeah, cheers, Teddy. Cheers, guys. And thank you for coming. Hey, sorry there's so few of us. Obviously, it'd be more fun if there's more people because can talk on the mic and stuff. But we will, Satenda and Arthur, I'm sure, will be phoning a lot of parents to find out why exactly attendance is so bad and how we can, maybe we'll have to reschedule or something. I don't know. But we'll see what happens. Enjoy that, guys. Cool. Cheers, cheers. Mm-hmm.